Now, let me show you how to make use of the ICE table to solve for combustion of hydrocarbons questions like this. Okay, so let's first understand what is this ICE table. So I'll give you an analogy. So let's say I want to make a burger. Okay, to make a burger, I will need 2 pieces of bread and 1 piece of a patty. Okay. So I have an ICE table. The ICE table stands for initial, change, and the end. So example, if I start with 5 pieces of bread and 2 pieces of patty, at the start, I will have 0 burgers because I've not started making any burgers. The limiting reagent, okay, will be your patty because there's only 2 of them. So you -2, ending up with 0, okay? Your limiting reagent must be completely used up. You will use up 4 pieces of bread and you will form 2 burgers. So at the end, you have 2 burgers and you have 1 piece of bread remaining. Okay, the important point that you need to notice here is out of the I, C, and E, the only thing that follows the mole ratio will be your C. Okay, your C will follow your 2:1:1 ratio. Okay, 2:1:1 ratio. Okay, so this is what you need to take away from your ICE table. The C will follow the mole ratio. Now, how do we do this ICE table? First, balance your combustion of hydrocarbon as per normal. Give you X CO2 and Y/2 H2O. Do an ICE table. In this case, they give you the volume of gas and you can use it in your ICE table rather than moles. By right, your ICE table should be done in terms of moles, but because the volume of a gas is proportionate to the number of moles, because number of moles is equals to volume of gas divided by molar volume, which is a constant. So you can see that the number of moles is proportionate to volume of gas. So let's read the question. There's 40 cm3 of gaseous hydrocarbon. So I'll put 40 here. There's 400 cm3 of oxygen. Okay, at the start, I have not burned anything, so CO2 will be 0. At room temperature and pressure, water will be liquid, so I will ignore it. The gaseous hydrocarbon will be a limiting reagent, so this will be -40 and this will be 0. Okay, let's read further. The volume of gas remaining after cooling to room temperature is 320. So this means that the total gas left will be 320. The leftover oxygen as well as your CO2 that is formed is 320. This was reduced to 40 cm3 by addition of KOH. KOH is a base. Your base will react with your acidic gas, which is CO2. Okay, so therefore, when they say this was reduced to 40, this means that the oxygen gas leftover was 40 cm3. And since this is 320, this will be 280. Okay, so the CO2 form is 280. So I'll just put this in, and this will be -360. So now it comes to our very important conclusion. The C relates to the mole ratio. Okay, the C will follow the mole ratio. So if I continue doing this, let's compare the mole ratio of CSHY to CO2 over here. CSHY to CO2 is 1:X. So we put 1:X. Okay, and based on the C, I can get the mole ratio here. Sorry, over here. 40:280, which means 1:7, which means the X is 7. Next, to get the Y, you just compare the CSHY to O2, which will be 1:X plus Y/4 over here. 1:X plus Y/4. We can compare that with the mole ratio, 1:9, which means X plus Y/4 equals to 9. And since X is 7, Y will be equals to 8. So we can get our formula C7H8 easily. So this is how you make use of the ICE table to solve for combustion equations. So this is 1 minute of chemistry. See you the next time.